Good morning, dear students. So this is a video of class 9, and in this video we are actually going to discuss about the explanation of laws of chemical combination. And we have actually previously done about the Dalton's atomic theory postulates, and we will discuss this topic on the basis of that postulates. Okay, now so here you can see that it is written the law of chemical combination are explained by following postulates. So we will actually discuss about the laws of chemical combination, but on the basis of postulates. So that topic is essential to understand this one. Okay, now so you have done a numbers of postulates which has been given by the Daltons. The very first one, how many laws of chemical combination you have done in your syllabus? First one, law of conservation of mass. Second one, law of constant and proportion or definite proportion. Again, so you can see that in that law of conservation of mass, what was the law of conservation of mass? Quickly, I am actually giving you some idea. If CaCO3 is there, CaCO3 is there, on heating it will give CaO plus CO2. Okay, now this one it has given. Okay, so this one is 100 gram. Okay, so this one 40 plus 16, 56 gram, and this carbon 12 plus 32. Okay, 44 gram, it will give 44 gram. So together 44 gram, 44 plus 56, it will give 100 gram. So what you have understood, that this 100 gram, this 100 gram should be equal. Okay, now so law of conservation of mass you have understood previously. You have also we have discussed in the one of the video. So law of conservation, we know that total mass of the reactant and total mass of the product should be equal, and the number of atoms in the reactant side and on the number of atoms in the product side should also be equal. Okay, now so here we are actually discuss about the law of conservation of mass was explained by which postulates. So you can say that you should know about this one. If I have written here CaCO3, and on heating CaO plus CO2. So law of conservation of mass, which postulates explain? In this one, you can see one calcium is there, one carbon is there, three oxygen is there. In this side, product side, one calcium is there, one, two, three oxygen is there, one carbon is there. So one calcium, one carbon, one carbon, three oxygen, all are equal, all are equal. So we can say that the atoms neither created nor destroyed in the chemical reaction. That postulate will explain the law of conservation of mass. Okay, now here it is written, the element, the elements consist of atoms, and these atoms can neither be created nor be destroyed. So that postulate will explain the law of conservation of mass. Understood? The second, law of constant proportion. Law of constant proportion was explained by which law? Which postulates? So you can see that here it is written, the elements consist of atom having fixed mass and number of, and the kind of atoms in each element in a given compound is fixed. That postulate you have done, and there I had actually explained that one, the example of water, that in that one, water, hydrogen and oxygen, that elements are every time fixed. Okay, na? And kind of atoms is also fixed. So you can see second law of constant proportion has been explained by which postulate? Suppose H2O I am talking. H2O is a combination of hydrogen and oxygen. Number 2 hydrogen, 1 oxygen. Okay, na? Every time for making water, it will contain hydrogen and oxygen. Yes, na? Every time we are talking about this one. So you should understand that which law, which postulate has actually given that the element, that postulate in which it is written the element consists of atoms having fixed mass and number and the kind of atom. So kind of atoms, that one is hydrogen and oxygen in water. Okay, and masses you can see 1:8 mass every time. We have discussed about that now. So for making that compound, number of atoms and the mass number will be fixed every time. Okay now. So now explanation of the law of conservation of mass. Okay, so you should understand that one, that wait. Okay, so explanation of the law of conservation of mass, and in this one Dalton said that the atoms are the smallest unit of matter. You can see here I have made this one again, a smallest particles of this element. Suppose this one F is an element, and here I have taken one circle is one atom. So this atom cannot break again. If this atom will not break again, then can we say that law of conservation of mass can be broken? No, same mass would be there in the reactant side as well as in the product side, and the number of atoms in the reactant side and the number of atoms on the product side would also be same. So that one was the basis he actually discussed about that one. Here it is written over there, atoms are smallest particles. Okay now, and that cannot further divided. So if the atoms will not further divided, if the atoms will not further divided, then the substance cannot be destroyed during a chemical reaction. So that one was the basis, and here due to this reason mass remains constant, and if mass remains constant, mass will not decay in a chemical reaction. So total mass of the reactant side and total mass of the product side would be equal. So that's why it is the basis of that one explanation of the law of conservation of mass. And if the law of mass is not decreasing, decaying, increasing, that means number of atoms is also not decaying, not losing. So that one is, we can say, the number of atoms in element side and in the product side will be also equal. Okay now, here we can see, here it is given one of the reaction we have taken CaCO3 arrow, you can take, it has given CO plus CO2. Mass I have already calculated in the previous slide, 100 gram of CaCO3, this one 56 gram, this one 44 gram, together it will make 100 gram. So 100 equal to 100, mass neither be created nor be destroyed. Okay now, so that one is equal. And also you can see one calcium, one carbon, three oxygen. Okay, in previous video I have discussed about that one. In product side, one calcium, three oxygen, one carbon, so that one is also equal. So that one is the explanation of the conservation of mass. Neither mass will destroy, neither atoms of the reactant and atoms of the product will destroy. And second, here you can see the explanation of the law of constant proportion. Okay now, so this actually we can say that postulate constant proportion means what? Constant proportion means everywhere you will see that hydrogen and oxygen, if I am talking about in the water, their proportion means if it is forming in the ratio 1:8, every time that one will form into the same mass. Okay now, from wherever you will take the water, it will form the same mass. Okay now, so here you can see, here it has given that the postulates of Dalton's atomic theory, that if I am talking about the any of the compound, their number of the different atoms, okay, would be in fixed ratio. Here it is 3:6, just like 3:6, not like that one 36, no. Then their mass will be also be fixed. Different atoms, if fixed number would be there, then their mass would be every time fixed. If the atoms is varying, that means mass will also varies. But never you will see in the reactant side and in the product side the atoms should be different. No, atoms should be same, but in the product side you have to take both of that one. If it is written with the plus sign, you have to count the total number of the atoms in the product side. You have to count the total number of the atoms in the reactant side. Okay now, so it here has given, suppose carbon dioxide if I am talking about. So carbon dioxide is one carbon, two oxygen. Okay na, and its mass if you will calculate. Okay na, so in the ratio you have to find out that one. Okay, and every time you will see that carbon dioxide if I am talking about, it will have same ratio. Okay na, let's see this one, NH3 I am talking about. NH, nitrogen atomic mass 14, hydrogen atomic mass, hydrogen has one atomic mass, but how many hydrogen is there? 3. So how can I write the ratio? 14 is to 3, because it cannot be divisible, so 14 is to 3 would be there. So that one is ammonia. Okay na, so here you can see that carbon dioxide is given, and every time we have to understand that same mass ratio would be there. Carbon dioxide from whatever sources we will take now, it will contain the same sources. Okay,